Example 6.8 is going to walk us through how to differentiate exponential functions when the base of the exponential is not Euler's number, e, but when it could be any number. For instance, in the function g, we have 1 to the x. Now, if you're anything like me and you don't like memorizing things, I don't have these rules memorized. I have to derive them every time. So if you already have these memorized, skip ahead to where I'm not working inside this margin. But if I have a function a to the x, and I need to differentiate this with respect to x, I need to rewrite that function using the base e exponential. So before differentiating, I'm going to rewrite this as a base e exponential natural log of a times an x. And I convince myself that I can do this because the base e exponential cancels with the base e logarithm, and I should return just that a value. And this power of x, in fact, maybe I should go slower. Let's first rewrite this as e to the natural log of a, and then that whole quantity raised to the x. Because I can do that, I'm turning this multiplication into iterative powers. Now here, the base e exponential and the base e logarithm cancel, and I just get that a back. So I do just get a to the x, which is what I wanted. So I can make this move right here. And if I can make that move, I can use the chain rule to tell myself how to differentiate this function. If I differentiate this function, this is equal to e to the natural log a x times the natural log of a. So this is just a to the x times natural log a. Okay, we're ready to differentiate now. Oh, when did I actually differentiate? This is here, the derivative. Okay, so if I want to differentiate g prime, or g of x to find g prime of x, I differentiate 1 to the x, and this rule tells me that will differentiate as 1 to the x times the natural log of 1. I then subtract the derivative of 3 to the x, and this rule tells me I get 3 to the x times natural log of 3. And we should notice the simplification here. Natural log of 1, that's equal to 0. So we end up at minus 3 to the x natural log of 3. You might wonder, why did this term differentiate to 0? Because 1 to the x, no matter what x is, it's 1 times itself over and over again. So it's equal to 1. Its derivative is 0. All right, let's keep going. Let me copy down my rule again. Oop, this should be a natural log. Okay, so t prime of s will be, by a chain rule, 3 times e to the 2s minus 4s plus a 3 to the s. Oops. Now squared multiplied by the derivative of the inside of that parentheses. So this will be e to the 2s times a 2 minus a 4 plus a 3 to the s natural log 3. All right, that was a big one. Now on to g of x. G prime of x will be 5x to the 4th minus a 5 to the x natural log of 5.